Okay, today we'll switch gear a little bit and talk about the next topic, essentially, which kind of like is a follow-up to some of the things we've seen. The first thing that I'm sure all of you have seen before is object-oriented programming. I asked earlier that whether basically any of you here haven't taken DSOP, right? And I think most of you have taken that. The thing is DSOP, which stands for data structure and object-oriented programming, right? We would talk about data structure a little bit, but minor, right? We're not going to talk a lot about data structure. We'll talk a little bit about object-oriented programming today and talk about how Scala enables something similar to object-oriented programming and how we can actually design a language to support it. Right. So to do a quick recap, on Tuesday we talked about this thing called polymorphic types, and as we basically discussed in the class, right, the meaning of polymorphic means that you can morph into many shapes, right, and that's exactly what polymorphic types mean. Basically, the way I think about it, right, the way I think about it is I put a variable on type. I can make it any type, right? So you can define a function called nth, which would get the nth element, right, of a list. And let's say a list of an integer, then you make sure the list input is a list of integer. Over here is a strictly typed data, right? Basically, you tell the program, well, you tell the computer that this list has to be a list of integer. The problem is, if I make an assignment to make sure you create this n function, but for a string, a double, and many other types, right? This gets annoying because you basically have to create multiple copies of the same function. So you can use polymorphic types. It's a list of int. You can say list A, list of T, and T is a type. Basically, it's a variable on a type. It's not exactly variable, to be honest, but to be the way I envision it, right? The way I remember it is like, okay, it's a variable on type. I can define it later. I can use it later. In reality, polymorphic type just means that these type can take many forms. We talk about folding as well, which basically means that it's operations done on a collection of things. This can be a list, this can be a set, this can be many things, right? This has to, the way it works is basically you apply the function. Given the initial state, apply the function on the first item, accumulate it. Apply the same function on the second item, accumulate it until you finish the entire list. And you can use a collection, for example, a list as dot fold left with initial state and some function which apply the whole folding process, right? This will start from the list XS. We will accumulately perform this function on each element of XS from left to right. We also talk about exception, which means that sometimes you write a program. Let's say you want to do x divided by y, but for some reason that y becomes 0, which means that you want to divide something by 0, which doesn't really evaluate, right? So in this case, the program wants to convey, hey, something weird happened, and I don't know what to do. So exception is a built-in feature of the language to handle these things. You also mentioned that some language doesn't really support like I guess the formal definition of exception, like C. C, the way it handles error, some parts of it use this trick called signal. Basically, would send a signal, error happen. Someone else would catch it, like the same concept, but it doesn't use the try catch keyword. It doesn't have the more modern exception support, like a modern language that available in, say, Java or Python. In Scala, you can use the throw keyword to raise an exception and you can catch it. One of the examples is throw new illegal argument, right? And when you have this exception, then a few things you can do. Basically, you can ignore, right? If you know that these are the features you doesn't support at the moment, or you know that, hey, you can't do anything with it. For example, you try to establish a connection into a client or a server, and your network is down. The function that called this establishing the connection will likely give an exception, timeout, right? Basically, hey, I'm trying to ping that server and it's not there. You can ignore it because basically I know it's the other program faults or the network fault or the IO fault, hard drive is down and things like that. You can ignore and terminate the program. You can catch and handle that. For example, if you have divide by 0 and you know that it's okay to just return 0. You can catch it and make sure you handle that accordingly, right? And today we will talk about the concept of collection and kind of extend it to object-oriented programming. Just give me 5 seconds. Let me change the temperature in this room a little bit. Sorry, the ACU is not working well in the morning. So let's create a rational number, right? What is a rational number? Can someone tell me what's a rational number? Awesome. So that is a perfect definition. It's a number that can be written as a fraction. Something divided by something, x divided by y. Those are rational number, right? And the first idea that I can do to create a rational number is, I guess I can use a pair. I can define a new type called rational, right? It would take an int and an int, right? And how do I add rational number together? So let's say I have x over y plus a over b. What would be the addition of the two numbers? All right, coffee time, guys. But what's the solution to this? Yep. All right, so that's the solution. So I can define an add function for my rational number. If I have two input, both of them are rational, right? I can do pattern matching, PQ, right? That would match to nominator P, nominator P, that's NP, denominator, numerator, my bad. I don't know what's with my pronunciation. Numerator of P, denominator P, numerator of Q, denominator of Q. That's NP, DP, NQ, DQ. We use pattern matching for computing the add function for two rational numbers. And we return the pair, right? Because we want to return a pair. The second items in a pair is the denominator, right? So that's dp multiplied by dq. The first item is the numerator, which is np multiplied by dq plus nq multiplied by dp. This is basically what we do here, right? And we can say toString, which is another built-in function for our rational, right? In this case, you can say if I have the toString where the input is a rational number, I can say again do pattern matching p.toString, which is in this case x over y, right? Oh, my bad. P and then slash q, right? So if your input is x over y, the toString function will return x divided by y, just printing those, right? Our second idea, instead of using a pair, we can use a record, right? Case class, this is our record. Case class rational. Rational take two input, numerator and denominator, n and d, right? And then if you have a function called add, which is a rational and a rational, you return again a rational number with the first input being p dot n multiplied by q dot d plus q dot n multiplied by p dot d. The second input is p dot d multiplied by q dot d. Okay. The two-string function is the same. Again, we use a way to access our record to get the numerator and the denominator. Okay. So you've seen that we're using this thing called a class before, and you might have been wondering, like, is this the same as class in Java? Actually, anyone here, since I think we talked about this since Tuesday, right? Whenever we see case class, have any of you wondering, is that the same as Java class? The answer is yes, kind of. Basically, you can use a class. Wait, why do the thing stay? Okay. So to use a case class, basically, we can use this concept of a class, right, to define a rational number. But instead of saying case class, case class means you're gonna build a record. A record can have an object as one of the type or a class. Right now, we're just doing flat out class, right? Class rational, class rational. Uh, anyone want to guess what does this do? Anyone want to make a guess on what does this do? Is this the same as something you've seen in Java before? It is a constructor, exactly, right? You build a rational number, and the input, whenever you say rational, 10 and 20, basically now you make the numerator 10, denominator 20, right? So now numer inside this object, I guess, is n. The denom is going to take the value whatever d have. Instantiation in Scala, you use the word new, right? So you can say val r equal new rational 3, 4. In this case, now r is basically 3 over 4, where 3 is, so what would r dot numer becomes? What if I say r dot numer? What will I get? 3, yes. And if I say r dot denom, that's going to be 4, right? So accessing r can be done by using this accessor dot. And if you want to implement an add function inside this rational class, this can be done by basically similar. So this, if you look at this, this is so similar to how you uh, implement a method in Java, right? So inside that bracket, because of the limited space here, assume that this go inside that bracket, right? Inside that bracket that you define a class. You define another function called add. This is the method inside the rational class. It takes one input called that. What does the word this do in Java? What does this do in Java? Whenever I type this is a keyword inside Java, and what does this do? It represents the object. Specifically, it represents itself, right? This dot something means that I'm talking about my own object, like my own value, right? So this dot numer is going to be referring to this own object. So let's say I have val r equal new rational 1, 2, right? And then I say this r dot add new rational 10 and 20. What do I get? basically it's what I'm going to do. I basically trying to add 1/2 by 10/20, which, I mean, at the end of the day, you're going to get the value 1, right? You can do the same thing for multiply. Right? You can implement a multiply by doing def mult that rational new, because you want to return a new object. Everything is immutable in Scala. Every time you create a new object, say the word new, you return new rational number, numer multiplied by that dot numer, denom multiplied by that dot denom. This is basically, if I want to do x over y multiplied by a over b, you're going to return xa over yb, right? You can override basically most object. This is kind of like the assumption that you have in programming. Most object would have the toString function. In this case, your class will have its own default toString, which is, in this case, doesn't really mean much. So you can do override def toString. Basically, it means that whenever I have this object R, I can say R dot toString. And this particular toString will follow this definition. So in this case, which is print numer slash denom. Any questions so far? Any questions so far? Quick recap. The same as Java, the same as how you create an object in Java. So if you are familiar with constructor and you're familiar with dealing with method in Java, same thing. It's just with Scala syntax. All right, it's the Java class in Scala syntax. You create a method by saying def the function name, and inside that is the input, and return whatever you want to return. Okay, right, and then make sure you are aware that things are immutable in Scala, so it has to be a totally new object. All right. So what's a public versus a private class in Java? Can someone explain it to me? What's the difference between a public and a private class? And also method, public and private method. Exactly. Public, as the name suggests, everyone can use it. Private means that whoever owned this class, whoever owned this method, you can use it. The owner can use it. No one else can, right? This is the same as if you look at land ownership, right? A park, which is a public land, everyone can go in and use it. You probably don't want to randomly walk into someone else's house because it's a private land. So that's the same concept here. And this concept has been used many places in computer science. So that applies to our functional programming. You can say private def GCD, right? And then define a function, which is basically greatest common denominator. Right? So basically this code performs a computation of GCD of A and B. Is a greatest common denominator A and B. And I can say private, wow, G equals GCD of N and D. And then I do def N over G, def denom D over G, right? And I say, hey, one of the requirements I'm gonna have is D has to be greater than 0. Otherwise, if D is less than 0 or 0, you're gonna print denominator must be positive just to make sure things are correct. By default, whenever you use the word def, like this, right? This means that it's a public thing. Everyone can use numer, everyone can use denom, right? In this case, everyone can use numer, everyone can use denom. But when you declare private like this, right? The scope, which is whatever bracket this code is in, right? The private code. Outside of this bracket, right, over here, you cannot access it. But inside, it's fine. Any questions so far? So within this bracket, you can define G and use GCD, and that's fine. But afterward, if you didn't really own it, you can't use it. And this work inside a class. This work inside a class. The thing is when you define a class, these private would basically tie, right, to the the class that you actually using. So let's say you have one class, two object, right? Object one and object two. And over here, this is object two, this is object one, right? The thing is, if you have a private thing in object one, the GCD of object one is owned by object one. No one else can call that function. The same thing goes to object two. It's the same class. It has a GCD function. Object two can call its own version of the GCD function. It's private to object two. Object one cannot call that. All right. And there's also a constructor, which we kind of covered already. We can define a constructor by adding the auxiliary constructors, by adding that. For example, you can define this, take one input, right? Which would mean I'm gonna call the constructor on this function. For example, let's say you defined it before. You define this. Let's say this is a rational number, like our rational class. Rational class right now take two input, n and d, right? What if I want to create a rational that takes one input, just n? This is how I can do it. If I have a rational with just one input, I basically means that this n go to the numerator and denom is 1 because of this definition, right? And notice how we can use this to self-reference our own earlier constructor. Basically, when I call this in bracket, this means the earlier constructor, it refers to itself. And here's some example as well. You can create this less function after we just do the definition of rational number about 4 slides back, right? 4 slides back we have definition of rational number. Then we can compare if numerator of this object multiplied by that dot denom, is it less than that dot numer multiplied by denom? Basically, this is basically trying to compare x over y. Is it less than a over b? This particular, this is this, and this is that. Is x over y less than a over b? And yes, exactly. When you talk about self in Python, the same thing. So the question is it kind of like a self keyword in Python? Yep. This is self in Python, right? And because of the assumption that whenever I call numer inside its own object, this is basically the same as this dot numer. It's another like shortcut you can do. You can overload operator. So what's this? Have you seen this before? Overloading operator? Yeah, okay, someone did. Awesome. So basically, let's say you define a rational, right, number again, called R and S. What if I just flat out type R plus S? What will happen? what will happen is just type in R plus S in Scala. It's gonna yell at you. The reason behind it is the add operator. It knows how to add int and int. It knows how to add string and string. It knows how to add double and double. It doesn't know how to add rational and rational because we haven't give it to them yet. We haven't give it to the program. Overloading operator means that let's say there's existing operator like a plus sign, a multiply sign, right? And I say, hey, I don't want to do r dot add all the time. I just want to be able to do r plus s because I don't want to type, right? You can overload it. The overloading plus operator can be done by doing this. Def, look at this, def plus. You can define it inside the class. Def plus, if you take in rational number, this is what you do. Basically, the dot 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 fill in the function. Basically, that's supposed to add this dot something multiplied by that dot something plus this dot something multiplied by that dot something over this dot denom multiplied by r dot denom, right? R is the input. Basically, you can do it for the plus, minus. If you want to just do a negative, negative means it's a unary operator. It takes only one input, right? A minus B, it means that I'm going to subtract B from A. Negative B means the negative value of B. This has the same keystroke. You type in this dash, but you can refer to the negative version of this keystroke by say unary underscore then the operation name. And keep in mind, there's one quick thing that I want to make sure you keep that in mind. It takes the same precedence rule. So if you overload the operator, amongst plus, minus, multiply, and divide, which one does the computer do first? What's the first operation? If I have a long max operation inside one line, A plus B plus C multiplied by D, which one will be done first? The multiply, right? The divide would be done first, then the plus and then minus. So make sure when you overload the operator, it follows the same rule. The add sign will get done after the multiply sign. Make sure that that is still intact, right? Otherwise your program might run into bugs. Any of you here seen the abstract class before? If you do, can you define it for your friends? What is an abstract class? Yeah, it's kind of like a template for a class, right? That contains the method to be implemented. It's kind of like it's an idea of this is how I want to build my class, but I'm not going to tell you how I did it, right? You convey the idea, but the actual abstract class doesn't really give you the discrete meaning or well, not the discrete meaning, but like the actual thing, right? It's kind of like abstract art where I look at it, hopefully I got some idea. Many times I don't even know what they're trying to do. But if I look at abstract art, the key here is you're conveying the template, the idea that the artists are trying to tell you. But if you look at the art itself, it doesn't really contain the detail, right? So what if you want to make an abstract class? Well, you all have answered that. What is an abstract class, right? So let's say we want to create the following thing. You want to create a set of integer, and you know that there's going to be an add function, which basically you know that the add function will take in one input and add that number to my set. Basically, union the current set with that one additional number. and it will have the has function, which check if X is in a set. How can we specify the interface, right? The abstract class, the first thing that you are going to learn in Scala about this abstract class is how to create an interface. Let's create an abstract class. This is easily done similar to Java, say abstract. All right. And inside, you know there's going to be an add function. Add, take one input integer, it return int set, right? Because you are union and you're going to return a set. It will have the has function and it would return a boolean. Any questions so far? So this is basically pretty self-explanatory. Is this similar to Java? Is this really similar to Java and Python? Anyone here not, I hope you've seen some version of this before. So in Scala, it looks the same. This means that we can implement it later, right? You can implement this later. Right now, the computer will know that's going to be a class called inset. This class has two methods, add and has. Add method would return an inset. The has would return a boolean. I don't know what I'm going to do with that yet. I only know the function name and the return type. To implement it, let's say you want to implement this using a linked list, right? Because the way you implement a set, you can do it in many, many ways. You can use a linked list. You can use an array. You can use a vector, right? So let's say I want to use a linked list. So I can say class empty extend int set. Basically, the extend is the keyword. It extend the int set, and now I'm going to create a class of empty. It's an empty set. It's an empty set. Does empty set contain any value? No, right? It's an empty set. I want to implement using a linked list. So the has function would return false for sure because it's an empty set. Then you add the function called add, right? When you add something to an empty set, you're going to get that a set containing that item, right? A set containing that item. So you can say new non-empty x and new empty. It's x that points to an empty set. The non-empty set, because we actually now refer to the non-empty set, the non-empty set is defined by you have the elements that follow by the rest of the elements in my set. Elements and other things in my set. The has function basically checks if x equal to element. If yes, you return true. The has function return true. Otherwise, you check if other has x. You check if other has x. Recursion again, right? Has function, check the first item, does it match? If it does, return true. Otherwise, check the rest of it. Add function to return new non-empty, and you append x to this own thing. So you notice, right? You notice that both empty and non-empty extend the class inset. So I'm going to go back one slide. Go back here. You notice there's a keyword called extend that I put in here. It says I'm going to extend the definition of my inset, which was declared as an abstract class. Now I extend it. I'm trying to make sure this becomes a reality. I extend the inset with the class called empty, and I extend the inset also with a class called non-empty. And because we have both definitions, they can be used to implement our inset. And notice that both would conform to the template that I said earlier, which means that the inset has to have the has function and the add function, right? Inset, which is the abstract class, so this thing is the abstract class, is a superclass to empty and non-empty. Basically, what does it mean is the empty class And the non-empty class is a part of the inset abstract class that we defined earlier. Vice versa, the empty and non-empty are the subclasses of the inset. So this is basically object-oriented programming recap. Everything would have this capital letter object as a superclass. Everything is under object. This also include whatever you type in the REPL statement, which is your console. Whenever you are typing something in Scala, one line, that's under the object superclass. And this also means you can override implementation of whatever's in the object superclass, right? And because we talk about object, we can use that concept to kind of like sometimes we know certain things will have only one copy, right? For example, the empty set that we said earlier, well, there should be only one null set, right? Basically, it's just an empty set, and everyone can extend from it. It's just one single empty set. That's one definition. No numbers in there, so you don't really need many copies of that. In other language, this is the static class. Anyone here seen the keyword static before? So same concept. In this case, you know there's only one singleton thing, only one empty. So why create many copies of empty? It's a waste of space, right? It's a waste of space, so you can create this singleton object. The way you do that, instead of called class, you use the keyword object. So over here, object empty extend inset, right? Object empty extend inset. You might have seen this example before with the deck of cards example, where you have case object king, case object queen, case object jack, and case object ace, and then case class number, right? Because number can take 1, 2, 3, 4, 5. I mean 2, 3, 4, 5, 6, 7, 8, 10. But there should be only one object called king, jack, queen, king, and s, right? Same thing here. There's only one singleton object. For empty, why create multiple different objects that represent the same thing? These would basically define an object that called empty, and no other instances of this object can be created. So one more thing, empty evaluate to itself because it's a value. It's now a value. All right. So in the book, I think in class 6 is at the end of the slide decks, and somehow I put in class exercise 7 here. Let's hold off to in class 7. That's for actually next week. My bad. So I'm gonna skip this. I'm gonna skip in class 7. In class 7 comes next week. My bad. We are working with in class 6 that come toward the end of this lecture. We are actually going to switch gear, move on from the concept of object-oriented programming, and go into the concept of first-class function, right? We're gonna talk more about what is a function as a first-class citizen, and what can we do with it? Because this is a powerful concept in computer program, right? If you use function pointer before, it's something along that line, but it's much easier inside functional programming. So the headache from function pointer would, I think, disappear somewhat. We'll take a quick break just so that we all can get some breath. If you have questions, feel free to ask questions because we're switching the topic from object-oriented programming in functional programming to how do you use function as a first-class citizen. Let's do 5 minutes. So we will resume at 12:56. All right. So we'll resume at 12:56. Hopefully get water, get coffee, whatever you need to make sure you freshen up. All right, and we'll see you guys in about 5 minutes. Okay, so let me pause the recording. All right, so let's move on to the next topic we want to cover. I want to cover today. I said we without actually even asking you whether you want to cover this or not, but we need to cover it today. We are gonna dive deeper into the concepts of functional, like the core concept of functional programming, which is let's treat everything like a function, right? So when you have a first class function, the first thing that I would need to make sure that you are aware is every function has a value, right? Remember our return type, every function in Scala would have a return type, right? So what does it mean? It means that function, evaluate your value, right? So conceptually, if it's a value, I can pass function in and it can return a function, right? Basically, if I know function is a value, or eventually it becomes a value, so I can use that value as an input to a function, or I can return a function as an output because eventually that's value, right? So for example, if I want to create a function that repeats things n time, is think of it as almost like a loop, right? I want to repeat something n times. I want to repeat function, let's say a function called f, right? Uh, I want to repeat function f n time, something like this, right? You've seen this before in mathematics, right? You can call a function again and again and again and again and again. Same concept, and you can do it by calling this particular writing it in this particular pattern. F, in this case, take input A, return A. These basically mean, this whole thing basically mean F takes type A as an input, return type A as an output. And function n times is an n times on the type A is a polymorphic type. It can be int, return int. It can be string, return string, whatever, right? It can be whatever type you want it to be. N is an integer because we want to repeat it n time. X is the initial thing you want to call, right? The first time you're going to return X. So X has type A, and you again return type A. If n equals 0, this is where we are right here, and this is X. Basically, over here, n is X, right? So to be a little bit more precise, let me erase this. This is what we want to do. We call f of x of x of f 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 x n times. This is basically what we're trying to do here. We want to do this n times. So when n is 0, you return x, which is this particular instance. Right? So this is when n equals 0. Otherwise, you call f, right, f of n times f n minus 1 x. Basically, let's break this down. Basically, there's a function call for f. Inside here is a recursion on n times. But now we decrement n, right? Because we finish applying f one time. So if you have to do it n times, in this case, the input instead of n goes as an n minus 1, right? This is one quick example. I'm not saying it's the best example. So let's actually use another function as a separate example. So let's actually see what can I do if I want to use function as inputs, right? Let's say I want to use function as input, and I declare these three functions. So look at the definition, and now tell me what does this do? 1, 2, 3, and 4. So the first thing I'm going to ask you, what's the answer to 1? What would be n times triple 7, 11? Let me do this to give a quick example for the first one. Someone, oh, sorry, I think someone turned on the microphone. Sorry, I can hear an echo, so I need to turn off your microphone. Do you have a question? If you have a question, turn on the microphone and ask now. I'm sorry. Long pause, I guess. No, that's correct, actually. That's awesome. So in the meantime, someone already solved it. So over here, 11 is our x, right? 11 is our x. And we want to repeat triple 7 times, which means we're going to call this function 7 times. So that's basically 7 multiplied by 3 multiplied by 11, right? What about the add 2 for 9? Now x here is 9, and we do this 4 times. So it's 9 plus 2, that's the first time, plus 2 is second time, third time, and fourth time, right? And now let's say I want to do detail to list of 3, 5, 2, 4, 9, 7. The third one actually is kind of like a trick question, actually, because detail, it demands you specify what the heck is T, right? So you need to go with this. You need to go with this, but basically, if you go with that particular detail, you're correct. That is basically 2, 4, 9, 7. Right. The third one is you can try this in Scala. I'm pretty sure it would basically tell you that detail is for type of T, and you haven't really defined type. You need to specify T is now integer. All right. So now this is how you can use function as input, right? You look at this n times, and triple, add to, and detail are 3 different functions. And you can use it for our n times function, right? The same logic follow. What if I use function as the return type, right? So let's say I define a function triple n times. Basically, what does the function do is they're gonna have a triple, right? 3 multiplied by x, and we call n times with triple n and x, right? Notice how this is a function. So basically, this return n times triple n x, right? And it doesn't really return a value. It returns a function. It returns a function. You can use a short form as well. These 2 functions are the same. These 2 functions are the same. I just want to show you that instead of using this equal curly bracket, you can do a short form, which is this arrow sign. It has the same meaning. This means that our short form is, this is a function that takes an input of type int, right, which has been specified right here. That's the input, call x, and return 3 multiplied by. So that's a short form. This equal greater than, this arrow thing means that the left side is the input to your function. The right side is whatever you want to return. You can use this in Scala. It would make things shorter. To be honest, I use this quite a lot when I want to use function as an input or pass it out as an output, right? So now that you've seen both like method, which is a function inside a class, versus a function, which is what you just saw many, many times. When we uh when we write def and then the function name, this is not really a function. Def, when you have def with the parameters, it has actually a method, right? This is kind of specific to each languages, so you need to follow the language specification. In Scala, this is treated like a method. So because it's kind of support object-oriented programming, and everything is under that big object class, right? So that's a method. So in Scala, method can be polymorphic. But in Scala, if you want to use a function, yeah. Oh, that's a great question. So if you want to call a function as a parameter, right? A function as a parameter that you have to, so the question is, do we have to set the parameter as a return type of the call function? So let me break it down and make sure that I got the question correctly. But I think your question is basically, does the type of the function have to match the definition of the function calling it? Is that the case? Is that your question? Yes, and the answer is yes. Basically, you need to make sure if you follow the logical definition of the type of every single function you have in the program, basically the requirement is it all have to match. The type has to match, right? So if things are polymorphic, you can define later, but if you define the type, everything has to have the matching type. A function has the type of input type creating output type. So eventually, once it becomes the value, the type of that function is the return type, is the return type. uh, which actually goes into this particular definition I just say here. In Scala, when you use a function, they are never polymorphic. It will have a value and it will have a type. It will have a type. For example, increment, right? Increment give a functional form. It takes an int and it will return an int. Basically, you take an int x, you're going to return x plus 1. And now we talk about type. I kind of want to kind of redefine the type system for a function in a little bit more formal way, I guess. For now, let's assume functions are polymorphic, right? So our n times function, it takes a, which is a function of a to a, number, which is an integer, and x, which is also the type a, and it returns a, right? This function n times, will have this type, this whole thing. What does this mean? What does this mean? Let's break this down. What's the input to the function n times? What is our input? So what's the first input? It's a function f, right? And what is the type of function f? It takes a and return a. It actually, to be really precise here, this is the type of f, which is a arrow a. A arrow a means that it takes in a, it spits out a. So that's our type for f. arrow A is it takes in input A, it spits out output type A. What's the second input in our n time? N, right? The n has a type int. The third input is x, has a type A, right? What's the return type of n times? What's the return type of n times? Again, an A, right? Because we specified right here, so it returns A. Whenever you see the arrow, it means it spit out this as a return type. So the type of n times is it takes 3 inputs. The n time takes 3 inputs. The first input, the second input, and the third input return one type of output, which is A. The second input is int. The third input is A. The first input is a function, so it takes an A, returns A. So that's the type of the first input. And this is the whole type of n times. And in this example, A is a placeholder for a type. It can be integer, it can be string, it can be any type. And this function doesn't always have to be polymorphic, right? You can do something like this. So instead of a function that takes in type A, which is a polymorphic types, our function times until 0 takes in int to int, take int, right, and then return an int. So this particular function will have the input of int to int as the first input, int again as the second input, and it returns int as the result. Any questions so far? And now I feel like I'm too jumpy because I had too much coffee. Also, don't know, I just sip more. If I'm going too fast, guys, let me know. I'm too high on caffeine right now. All right, so this is basically how you can define a type of a function, right? The next thing we can do is whenever you have a function, this is back when we talk about evaluation, right? Evaluation means that we have to evaluate a big equation, expression into a value. Function is a value, which means you can reduce that function into a value too. So consider this example. Let's say I have if x multiplied by y plus 2 less than 10 or not. True, true, false, right? To reduce this is the same, basically, this is the same as do those call by value, call by name evaluation. So this apply similar in a similar fashion as expression, which is our first and second lecture. So you can rewrite this once into if, right? If x multiplied by y plus 2 less than 10, true or false. This is going to be, well, you can collapse this, right? Because if that's true, it's going to return true. So you just return just true. You can rewrite it again to reduce the function to just x multiplied by y plus 2 less than 10, because this is basically equivalent to this. Because if that statement becomes true, it's going to return true. If that statement becomes false, it's going to return false. So this is how you can reduce a function. And believe it or not, so in modern compiler, there are many tricks that are being applied to be as lazy as possible. And one of the things is whenever this thing can be reduced, the compiler reduces it for you before you actually run it. So yes, so the question is we don't have to put an if, right? That is true, because if you look at this statement, expression, this function 1 and this function 2, they are the same function. Regardless of the value of x and y, they are going to return the exact same thing, right? Because the return value is Boolean, so yeah, why not? And one side thing that I want to get out of this particular example is this is actually done when you compile the code. Modern compilers do a lot of this thing for you, right? there's a lot of things that are going on inside whenever you compile and whenever you run inside the computer system, inside the compiler world, to make your program run faster. And the way you construct each of the language, it actually assists the compiler and assists the system in a different way. So it does make quite a lot of impact in terms of performance. We will actually look at performance in the second half of this class, and we'll look at how to write a really hopefully fast program and still correct. So let's do another example. Let's go back to our n times function and the do tail thing, right? So can I rewrite the following function into something like this? The answer is yes. Basically, I can rewrite it this way. It's a function that has a short form. Take a list of int, return just the tail of that list. Then I can make it even shorter. It's function n times, right? And the type of n times is the list of int. By default, I'm gonna just get whatever input list that comes in, the tail of that, and do it twice. So you can do this particular reduction as well. So once you have a function, in many cases, reduction can be done. And again, I want to stress that the key here is it doesn't have to be done by you. Sometimes you can do it, that's fine. But if these things are obvious, compiler would do it automatically for you. So underneath, when you click that run button, on IntelliJ, the first thing the IntelliJ is doing is it compile the code to make sure it's runnable on your CPU, on your computer. And before you run it, these processes are being applied. What about more abstractions? So let's talk about this a little bit. So consider this example. I have a lottery, and my lottery takes a function as an input for the first input. Yeah, sorry, that was a question. Yes. So the question is on this particular example, right? And the question is for the first declaration, the second, and the third. The difference between the first and the second is, in this case, I don't have to define the definition for detail. Yes, you can kind of use the short form. In this case, you don't have to do def detail and blah, 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 and we'll just use the short form. The reason behind this, to be honest, is kind of like we all love to be lazy, right? I can tell you the reason I go into computer science in the first place. I want to play, well, I play computer games, a lot of computer games, and I want to study the computer. And one thing I love about engineering in general is I don't have to remember so many things. I don't have to go into biology and remember so many terminology, right? I want to be lazy. Many things we do and we invent in terms of tools in computer science are actually for that purposes. We want to be as lazy as possible. You want to get the maximum production out of the human time. So that's why writing thing in short form is better in general, because you don't have to write a separate function, use a function as your input. Just do a short form if you can. Consider a separate example. I have a function called silly lottery, right? My question is, what's the type of this function? Can someone tell me what's the type of this function? It returns a function, actually. It returns a function because it either return this or this. Right? So the return type is a function that returns an int. So this has a type, it takes an int, return an int, right? So that's our return type. What's the input type? Exactly, you're correct. So it's int. Well, actually, let me write it out. This is our return type. This is our input type. right? Basically, it's something like this. If we give an int to an int and another int, we'll get an int to an int. I know that doesn't help at all. I don't even know why I said that. But if you break this function down, look at the input. The first input is a function that takes an int, return an int. So that's our first input type. The second input type is an int. And you just look at the output type by carefully staring at that two lines. And then you realize that it's a function that takes an int, which is x, return an int, right? You can then bind this to a variable. For example, you can say val magic equals silly lottery x 3 multiplied by x minus 9 and 25, right? So this is our first input. This is a function. And this is our number, which is n, right? So what would be magic 21? What is magic 21? To get magic 21, right? The first thing we can do here is, okay, what is silly lottery of this whole thing? It check for f of n, right? It check for f of n. So what is f of n? What is f of n? Basically, if f is here, n is here. What is f? F takes in 3 multiplied by x minus 9, right? So that's our f. N is what? What is the value of n in the magic 21? Magic 21, remember magic 21 is basically silly lottery of this function. So our n is this, n is 25. This replace x, so basically 3 multiplied by 25 minus 9. What is that number? That's 75 minus 9, that is 66. So this whole thing is 66, right? Is 66 even or odd? Even, right? So it's going to return. So this whole thing is going to return what? If it's even, it returns this thing, right? So that's x over 2. And what is x? What is x? Magic of x now will equal x over 2. Magic of 21 is going to be what? 21 over 2, right? Any questions? Because I feel like there's a lot of questions right now. All right. Do you want me to do it again? Or is it clear? Anyone here want me to do it again? Okay, awesome. So I'm gonna erase this whole thing and I'll start again. I said magic equals silly lottery of these things, right? So I say val magic equals silly lottery of something. What does silly lottery return? What does silly lottery return? It returns a function, right? It returns a function. Because if you look at this, it's a function. Well, after we do line number one here, we'll get a function. What is that function? It's the function that take in integer and give you integer, right? So right now, magic without any input is a function that are waiting to take one input. That's why you can basically call magic 21, but we'll go back to that later. Let's look at the line number 1, which is silly lottery, right? Silly lottery of the function, let's say g. and 25, right? And G is this whole thing. This is G. This function G, right? If you look at this, which means we have to now refer to this function that we defined earlier, right? In this case, what is G and what is N? Oh, my bad. What is F here and what is N here? What is F and what's N? All right, easy one first. What is N? What's the value of N? F is G, awesome. And what is N? 25. Yes, you got it. So let's go through this, right? Now, what exactly is G? What's the full thing for G? It's basically you take in input, you return 3 multiplied by x minus 9. So that's our G. This is N, right? All right, with me so far? Okay, so let's go to the first line. The first line is like, okay, if I do Fn, and for that, if it's divisible by 2, we will return that. So we say, we know that f of n is basically g of n, right? N is what? 25, right? This is g of 25, right? With me so far? Basically, this is basically g of 25. So what is g of 25? Can someone type it out? That's g. G takes in one number. Yes, that's 66, because g would take in that 25, right? And do 3 multiplied by n, and now n is 25 minus 9. That's 66. And 66 divided by 2, well, 66 is an even number. So this whole thing evaluates to true. With me so far, basically that line becomes true. Right? With me? Yes, no? So this whole thing, I'm gonna use a different ink color to make sure it doesn't really mix things up too much. This whole thing, return x colon int x over 2. That's the result. It returns a function, takes in one number, gives you a half of that number. So over here, magic of 21 is basically 21 over 2. Oh, where did x come from? That's a great question. Do you mean that x, right? This one. Ah, so that is whatever we define. Basically, this is a short form function. Over here, we just say, hey, it's a function. With me so far, basically, I'm going to return a function. And that function will take in an input, and let's call that input x. Your function perform x over 2. Basically, it's a function that takes in one input, and it returns half of that input, right? So that's you can replace x with n, you can replace x with m, you can replace x with a. It's the same thing. Basically, it's a variable to that function that you use as an input. Okay, so we will have more exercise about this when we talk about another concept called scope, which is I think in a 1 or 2 more lecture. Let me kind of quickly wrap things up, because to kind of like work through your assignments. The other thing that I want to let you know is Scala has built-in library for input and output, like printf. Or actually, it's called print in Scala. You can do scala.io.source and import this. You can import this thing to deal with any IO related things. For example, if you want to count the number of words in a file, you can say import scala.io.source. And then you can do source dot standard input. Standard input is your keyboard thing. Basically, whatever you type in is standard input. You can do store source of standard input, get lines, and then whatever function you want to call, right? Whatever function you want to call. So I definitely would recommend you to refer to Scala doc if you want to go implement anything that has to do with I/O. What are I/O? Input and output. These are things that is from your hard drive, things that's on your screen, things that's on your keyboard and mouse. These are input and output. Basically, most of the devices you have on your computer is done through this I/O. More details, Tech Consist Arc. We will talk a lot about this kind of thing. But I just want to highlight that this thing exists. If you want to print something, you can do this. In class exercise, again, do the unzip function, which again reverse the zip, but make it polymorphic. So the input can be any list of A and B. The second in-class exercise is a count wow, which basically means you take in a list of T and another key, and you count number of times that you see that key. Top K is basically you tally the element of X and return the element with the top K frequency. So let's say your list is, oops, I think there'll be another question come afterwards. So I'm gonna write it at the top. So let's say your list is 1, 1, 1, 1, 2, 2, 3, 4, right? And you do top 2. Basically now K is 2. Then top K would return 1 and 2, because 1, there's 4 of the 1s, there's 2 of the 2s, and it's 1 of 3, 1 of 4. So top 2 would return 1 and 2. And then this is basically dealing with object-oriented programming. Make a sum type that's called dessert, which can be one of the following. It can be a pie, it can be a smoothie, it can be a list, and smoothie is the list of fruits, and it can be a cake, which would have certain toppings name. Then write a function called isLiquid, and the input is the dessert type, and you return whether that dessert is liquid or not. I will leave it up to your judgment about which of these things are liquid. I don't want to admit this, but when I was like in the US, there was a time when I was in Florida, and there's a shop that actually put a cake, oh, actually it's a pie, in a blender, and it was actually delicious. Don't recommend it if you're more than 30 years old. You probably like get a heart attack. Up to you on which one would be liquid. I would recommend go with the normal human judgment. So that's your in-class exercise 6. One last thing is about our makeup class, and here are the slots. I'm gonna make a board right now, so bear with me while I'm making this board. In the meantime, let me stop the recording.